Hello my dear students. So I am going to continue with the lesson. We are discussing physical properties of pure substances. So you can remember so far we have discussed density, then we discussed melting point, boiling point. So now using these properties, we will see how we can classify these substances. We have already classified substances as elements or pure substances and non-pure substances. Now we are looking at the physical properties of elements. So we will see how we can use those to classify them. I have introduced that to you all. Now when I discuss the melting point and boiling point, I told you all about metals and non-metals as well. So we will see how we do the classification. Now let us see whether we can classify the elements that we identified as pure substances based on their physical properties. For that, we'll be doing an activity. Observe some physical properties of elements. So for that, we need these materials. We need copper. Then we need sulfur. Then we need carbon. When we say carbon, we will be using graphite. Then we will be using aluminium. And we will be using lead. So copper, sulfur, carbon, graphite, aluminium and lead. So this is what we will do. We have already seen these metals. We have used them for different purposes. I have showed you all these elements before also. So you're familiar with the properties. We are going to recall them, and based on those properties, we are going to classify them into two types. That is the metals and non-metals. So if there are certain properties, they come under the category of metals. If they possess different properties, they will be classified under non-metals. Is that clear, students? So these are the elements: copper, sulfur, carbon, aluminium, lead. In addition to this, you can consider many more substances. You can even consider magnesium, you can look at iron. Like that, you can consider many other elements. Is that clear, students? So once we do that, once we observe this, we will have to observe different properties or specific properties, and we will have to tabulate them. I have the table on the next slide. It is given in your textbook also. So before we go to the table, I have explained the method again here. Identify observations or simple activities appropriate to examine the properties such as metallic luster. What is metallic luster? First one, the shiny nature of surfaces. So that is metallic luster. So from the name itself, we all know metals have luster, the shine of metals. Then sonority. What is sonority? Sonorous sound. When you apply force, when you hit it on something or when you drop the substance on the floor, you get a ringing sound. Like how the bell rings, the normal hand bell, when it rings, you hear the ringing sound. That is a sonorous sound. Then thermal conductivity. What is thermal conductivity? Whether the substance, whether the element can conduct heat. Now when we cook substances, we use vessels. For that to happen, the vessel has to conduct heat. Otherwise, the food won't cook. So that is thermal conductivity. Then electrical conductivity. So what is electrical conductivity? The ability of a substance to conduct electricity. In the households, we have wires, conducting wires. You would have seen copper wires. So their copper has electrical conductivity. We will be observing that as well. Then malleability. What is malleability? You have heard about malleability, ductility. Malleability, when you apply a force, you can make them into thin sheets without the element breaking down. So that is known as malleability. Similarly, there is ductility. You can draw them into wires without breaking. So malleability, then there is brittleness. Now if you drop a pencil, the tip of the pencil, the lead of the pencil breaks. So we can say that that is made up of graphite, that is brittle. Quickly it can break into pieces. Glass is brittle. It can break into pieces. Whereas iron is not brittle. So like that, you are familiar with most of these materials. You are familiar with most of these elements. But here we will observe each of these properties. Considering them, we will classify them as metals and non-metals. So identify observations or simple activities appropriate to examine the properties such as metallic luster, sonority, thermal conductivity, electrical conductivity, malleability, and brittleness. You can have an understanding about this by reading the paragraph coming after this activity. So once this activity is given to you, once this is explained to you, I will explain each of these properties and how we can identify them. Do the relevant activities and record the observations using a table. Place a tick when the element has the relevant property and a cross if it does not have the relevant property. Is that clear, students? In the table, we have to say, you have to put a tick and you have to identify whether they have the relevant property. Then some methods which you can adopt to examine each physical property are described below. To investigate the physical properties, you can use either those methods or other methods after discussing with your teacher. You can come up with other methods also. There are some methods given to you. You can think of other methods as well. Is that clear to you all, students? So this is to identify different properties, all these properties, so that we can classify them into types. Is that clear to you? So like I said, I'm not going to do this in the lab, but what we will do is, we will recall what we know already. And based on that, we will classify them. So with that understanding, I will move on to the next slide, students. So this is the table given in your textbook. You are familiar with this table. So here you can see the substances are given. Iron, you know what iron is. We have so many iron structures in your household itself. You would have seen those iron grills, so many things made up of iron, so you know what iron is. Then copper, obviously you would have seen copper wires or copper vessels, so you know what that is. Then sulfur, of course, we don't use it at home, but I showed you all in the lab, so you have seen sulfur. Then there is graphite. Every one of you all use graphite. Why? You use pencil. The pencil lead is graphite. It is carbon graphite. So you know what that is. Then magnesium. Again, you have seen magnesium in the lab. Aluminium. Aluminium also you have seen in the lab. And you all have it in the households also. Aluminium foils. You might have seen that. Lead. Again another element. Lead. Then zinc, that is also another element. So these are all different elements. Then we will have to see whether they show luster, whether they have sonority, the sonorous sound, whether they show thermal conductivity, whether they show electrical conductivity, whether they are malleable or whether they are brittle in nature. One is filled for you all already. Now you can see iron. Iron has luster. It has a shine. How about sonority? Sonority, if you drop now a piece of iron, that will make a ringing sound. You can hear that. Even the bells, the church bells, school bells, most of the temples, all these have bells. And when they ring the bell, either they hit it with something or they have the bell inside it, the structure. When you pull it with a rope, you hear the ringing sound. So there they show sonorous sound or they generate sonorous sound. Then thermal conductivity. I'm sure you all know that. Vessels made of steel. Steel is a type of alloy of iron. So vessels made up of iron, if you keep it on the cooker, obviously they become hot. And if you touch it, you can feel the heat. So that means they conduct heat. So they show thermal conductivity. Electrical conductivity. Iron can conduct electricity. So that is also there. Is it malleable? Can it be made into sheets by applying force without breaking? Yes, you have seen structures made up of iron sheets. So it is malleable. Is it brittle? No. If you drop a piece of iron, it doesn't break into pieces. So that means it is not brittle. So all these properties, iron shows luster, sonority, thermal conductivity, electrical conductivity and malleability. Brittleness is not there. And these few properties, the first few properties, except brittleness, usually those properties are shown by metals. Brittleness is for non-metals. So from that you will be able to understand iron is a metal. Like that, we will have to observe many properties for all these substances. If we consider copper, copper you have seen, no? You have seen copper wires or even thin sheets of copper. It's a brownish color, shiny metal. So does it have a luster? Yes, it has a luster. Now if copper falls down, a piece of copper falls down, or if you hit a piece of copper with some other object, it will give rise to the sonorous sound. So sonority is there. Thermal conductivity. Copper vessels were used earlier. So that also conducts heat. Thermal conductivity, yes. Electrical conductivity. Most of the household wires are copper wires. So they can conduct electricity very well. So they have electrical conductivity. And malleability. You have seen copper sheets. It can be made into sheets. So malleability is there. But they are not brittle. They don't break that easily. So not brittle. Brittleness is not there. Then sulfur. Sulfur you have seen. There is a slight shine is there, a yellowish color solid, but that is not the luster. The shine, the luster shown by metals or iron and copper is different from the slight shine of the sulfur crystals. So it does not show luster. If you drop it, it will actually just break into powder. It doesn't give any sound. There is no sonority. Sulfur doesn't conduct heat. No thermal conductivity. It does not conduct electricity. That means electrical conductivity is not there. And also it is not malleable. If you hammer it, if you apply a force, it will just break into powder. It will not become a sheet. So brittleness is there. Now can you see the difference? First two, all these properties are there. Luster, sonority, thermal conductivity, electrical conductivity and malleability. I told you all those are properties of metals. Whereas sulfur does not show any of those properties, but it is a brittle substance. So it is a non-metal. We will be classifying it in a while. Then graphite. Graphite, now it does not show luster. That is not there. Graphite doesn't have a lustrous shine. It does have a shine. Again, you have to remember, students, when you look at the lead of the pencil, if you rotate it, you can see, but that's not the lustrous nature, or luster is not there. It doesn't make a sound. If you drop it, it doesn't give you a ringing sound. So sonority is not there. It does not conduct heat. Even if you hold the pencil lead to a flame, it does not conduct heat. So thermal conductivity is not there. But electrical conductivity, it does conduct heat. I will put it as an exception, a different color. This conducts electricity. Now you have heard about graphite electrodes. or in batteries, dry cells, there is carbon graphite. They conduct electricity very well. So that is a special feature for carbon graphite. Malleability, not there. They cannot be made into sheets. If you drop your pencil, like I said, the pencil lead will break easily. That means graphite is brittle. So can you see? No luster, no sonority, no thermal conductivity, not malleable. And it is brittle. Those are all properties of non-metals. This is an exceptional property. Now, graphite, although it's a non-metal, it can conduct electricity. You have to remember all those, students. Then magnesium. Magnesium has a luster. Now, you have seen no magnesium strips. When we take it out from the lab, when we take it out, if you look at the strip, it doesn't have a shine. But before the activity, what we do is we clean it with a sandpaper. Once you clean it with the sandpaper, the whitish color layer is removed. You see the shine of magnesium metal. So that has a lustrous nature. So magnesium luster, yes. Sonority, if you drop it, yes, it will give a sound, but not the thin strip. It has to be a thick magnesium plate. So that will give the sonorous sound. It will conduct heat, thermal conductivity is there. It will conduct electricity. It is malleable, that is why it is made into strips. Malleable, it is not brittle. So now can you understand? Magnesium, luster is there, sonority, thermal conductivity, electrical conductivity, malleability. No brittleness. So it has to become a metal. Then aluminium. Aluminium, yes, you have seen the shine of aluminium. Aluminium foil, aluminium vessels, they have the shine. They do have sonority. At home, if one of you all, by mistake, if you drop an aluminium vessel or even an iron vessel, a copper vessel, you get that ringing sound, sonorous sound that is there. Thermal conductivity, yes, that's why we use them as cooking vessels, aluminium. They have thermal conductivity. They do conduct electricity. Aluminium metal, aluminium plates, aluminium strips can conduct electricity. They are malleable. That is why we are able to make them into vessels or sheets. They are malleable. But brittleness is not there. If you drop an aluminium vessel, it doesn't break into pieces. It is not brittle. Is that clear, student? Then there is lead. Lead again a metal. Now lead has luster. It has a shine. You might have seen lead sheets or lead plates. You would have seen that in the lab. It does have a shine, silvery shine. But lead does not have sonority. It does not make the ringing sound. So that is also an exception. Lead does not make the sonorous sound. Then if you look at the thermal conductivity, yes, lead conducts heat and also it can conduct electricity. It is malleable, but it is not brittle. These are the properties of lead. Then if you take zinc, zinc again has the luster shine, that is also a brownish color. Metal, shiny metal, then sonority is there, thermal conductivity, electrical conductivity and malleability is there. But it is not brittle. So from these you will be able to identify the metals and non-metals. Usually luster, sonority, thermal conductivity, electrical conductivity and malleability are shown by metals. Whereas non-metals do not show these properties, but they show brittleness. There are exceptions. Graphite, although it's a non-metal, it does conduct electricity well. And lead, it does not have the sonorous sound, but it shows all the other properties of metals. So it is a metal. You all have to understand that, students. Now here I have discussed these properties from what you already know. Now after this, I will discuss simple methods to identify all these properties. So with that, students, I will move on to the next slide. So luster. What is luster? The shiny nature of element. To examine the luster, you can scratch the surface of the substance with a knife or clean it with a sandpaper. So I told you all, if there is a strip of magnesium, a magnesium strip, if you store it in the lab for some time, there will be no shine. Once you take it, it will be just a dull color. But if you take that and if you clean it with a sandpaper, you will see the shine. So that is the lustrous nature. Now you can remember iron, magnesium, copper, aluminium, zinc, all these have luster. To examine the luster, you can scratch the surface of the substance with a knife or clean it with a sandpaper. Is that clear? That is how you identify whether it has luster or not. If you scratch graphite with sandpaper or if you scratch sulfur with sandpaper, you won't see that lustrous nature. If you scratch it with a knife, what do we do when we sharpen the pencil? Don't do that normally. Normally you all are supposed to use a sharpener, but sometimes we use a blade, sometimes we use a knife. Then you don't get the shine. It just comes off. The graphite gets sharpened. So there you know that there is no luster. You have to understand that, students. So then we will move on to the next property, that is sonority. What is sonority? The ringing sound that you hear. When you apply a force, when you hit it onto an object or when you drop it down, you hear the ringing sound. That is sonority. The material used to examine sonority should be at least 1 millimeter thick. It has to be somewhat thick. Then only you can identify whether there is a sonorous sound or not. If it is too thin also, you can't identify the nature. It can be done by striking with a metal rod or dropping on the cement floor from a suitable height. So you can either strike it with a metal rod, then you will hear the sound, or you can drop it on the floor. Then also you will hear the sonorous sound if it shows the property. So here again you can remember, students. Iron, copper, zinc, aluminium, all those have sonorous sound. Sulfur, lead, graphite, they do not show sonorous sound. Is that clear to you? You have to remember that. Iron, magnesium, copper, zinc, all these have sonorous sound or sonority. Then the next property, that is thermal conductivity. Thermal conductivity. To inquire into the thermal conductivity, a change that can be observed during the transmission of heat has to be used. So when we say transmission of heat has to be used. For example, drops of candle wax can be placed on rods made of different materials and melting of the wax during conduction of heat can be done. So what do we do there? You have a small rod. Now on this rod, what we can do is, we can place a few drops of candle wax. This is the rod. You have the candle wax. And here you supply heat. If you want, you can have like a cardboard there. Cardboard. So that this heat does not melt the wax. To prevent that, we can have a piece of cardboard attached there. So heat is given here. Heat will be transferred through the rod. If it is transferred, you will see these drops of candle wax melting and falling off. Then you can be sure that they conduct heat. So they show thermal conductivity. So that is what you have to do. For example, drops of candle wax can be placed on rods made of different materials, and melting of the wax during conduction of heat can be done. Is that clear? So that is how we are supposed to observe thermal conductivity. To do that, we have an activity. I will move on to the next slide where we discuss the activity, and then we will observe the activity as well. Activity. Inquire into the thermal conductivity. Required materials, we need a Bunsen burner, then we need a tripod, and we have to use the metals, different metals, say for example copper, iron, aluminium. Like that, we can use different metals. Then we can use a candle there. So this is what we do. We light the candle, make few drops of candle wax on the metal. Similar sized drops would be ideal. Then what we do is you need to place all these rods on this tripod, and at the same time, simultaneously, the tips of all the metal rods have to be close to each other, so the heat will be provided evenly to all of them, and you observe the candle wax melting. Like I said, you can even put a piece of cardboard to prevent the heat directly melting the wax. So that is how you observe the thermal conductivity. That is the basic method. I will move on to the next slide where I discuss the method in a little bit more detail. So this is the activity. You can observe the diagram here, students, under method. Examine thermal conductivity. So on the table, we have the Bunsen burner. Then you can see the tripod. Now here you can see the metal rod, plate of insulator. That is this one. So that doesn't conduct electricity, such as asbestos. You all know what asbestos sheet is. So that is placed on top of the tripod, and on that only we place the metal rods. So on that you can see the candle wax here, and here you can see all the tips are close to each other. So then heat will be provided evenly. Then you can see the candle wax melting. Take similar shaped rods made of different materials that are equal in length. Place drops of candle wax on the rods and attach head pins to each drop. So you can either have just the candle wax, or you can attach head pins to the drops. Provide heat to the free ends of the rods simultaneously. So when the wax melts, if you attach a head pin, as mentioned here, then of course what will happen? The head pins will fall down quickly. So from that you can see heat is being conducted. There is thermal conductivity. Because of the conducted heat, wax melts, and because of that the head pin falls down. So that is a very good observation to show that the heat is being conducted, or the particular matter shows thermal conductivity. Is that clear to you all, students? So with that, I will go to the lab and do this simple activity where you all can observe thermal conductivity of different elements. Okay, students. So you all know now we are investigating the properties of metals and non-metals, the different types of elements. So under that, the property thermal conductor, or the ability to conduct heat. So here, in order to compare the thermal conductivity of different metals, I have prepared this setup. So here, as you can see, to this stand, I have clamped a wooden block, and to that there are 3 strips of metals fixed there. You can see this is aluminium, the first one on this side, and in the middle we have copper, and towards this end I have fixed an iron, a thin rod. So to all the three rods there have been candle wax drops there, and to the candle wax the head pins have been attached. So when we provide heat from this Bunsen burner on this side, one thing you all have to notice, students, there is a piece of wood there, a wooden small block. So that will prevent the flame from coming in contact with the candle wax and the pins directly. So the heat has to be transferred or conducted through the metals or along the metals. So that is what we are going to try and understand. So when we provide heat to this end, you will see that the heat has to be conducted, that is thermal conductivity. We will not see that, but you can see the candle wax melting and the pins falling down. So from that order in which the candle wax melts and the pins fall down, we can understand the thermal conductivity of these three metals. So now I am going to provide heat. So here students, you all can see when all three are given heat, you will have to observe the wax clearly. What melts first? Still all the pins and the candle wax are intact. Observe carefully. Still all the pins are intact, so we will have to wait for some time. We can also do this activity without fixing the head pins. You can only have the candle wax drops. So that also can be observed, the order in which they all melt. So now still the wax hasn't melted, so still all the pins are intact. You all can observe to a certain extent, students, this particular drop of wax, the first drop on the copper metal, that has started to melt, but all the other drops, and you can see the pin fell down. So that means copper was able to conduct the heat first. Still aluminium and iron, they have the first pins intact. So now you all can get an idea as to how the thermal conductivity is. So we will have to wait for some more time until the other pins fall down. Now observe the wax, students. You all have to look at both iron and aluminium, the two rods on either side. You all can see the melting of wax little by little. You all can observe it. It takes some time for the wax to melt, so you all can compare the thermal conductivities. Copper conducted heat fast, but still the second drop is intact. But the other two metals, still the first drop of wax are still there and the pins are still there. So here students, you all can see again the second drop of the second pin from copper, it has fallen down. So still you can see the conductivity, thermal conductivity of copper is more compared to aluminium and iron. So still we need to wait and see which one out of iron and aluminium that conducts heat better. So then only we can compare the thermal conductivities. You all can see the wax on aluminium is almost, it has the pin fell down. So that's the first one. So after copper, it is aluminium. Still the iron, it has the first pin intact. So that means the thermal conductivity of iron is very much less compared to copper and aluminium. But still we will have to wait till all the pins fall down. Even now you all can see students, the third drop of wax over there with the pin, it is still, it has almost started melting, and here also the second pin, that is also melting to a certain extent. So now but you all can see here the first drop of wax on iron, that is also starting to melt. So you can see students, the first pin from the iron metal has fallen down. So that was the least thermal conductivity. So from the observation so far, you all know students, copper, the pin fell down first and even the second pin. So that has the highest thermal conductivity. Then we had the first pin falling down from aluminium. So the metal with the second highest conductivity, and iron has the lowest thermal conductivity. So from these observations, students, you all can understand how the heat is conducted through different metals. So initially it was copper that conducted heat well. That is why the pins from copper rod fell down quickly. And now you can see the third pin also has fallen down from copper. But again, only one pin from each aluminium and iron fell down. Then that also after aluminium only the pin from the iron rod fell down. So from that we can compare and conclude and say that copper has the highest heat thermal conductivity, then comes aluminium, and finally it is iron. So from that you all know different metals have different thermal conductivities. Okay students, so did you all see the observations clearly? I'm sure you all did. What happened? When we place the metal rods with candle wax on it to the Bunsen flame, all the metal rods have to be close to each other so that the heat is provided uniformly to them. What did you all see? After some time, you saw the wax melting, and because of that, the head pins fall down. If we don't have head pins, you will still see the wax melting. Is that clear to you all? So we used copper, aluminium and iron. And you all were able to see that all of those conduct heat well. But the rate at which or the ability to conduct heat differs. You were able to see that from copper rod, the wax melted quickly. So that conducts heat better. But aluminium and iron, they take a little longer time for the thermal conductivity. But still, all these substances, all these elements, copper, aluminium and iron, they conduct heat well. So they show thermal conductivity. That is what we observe there. When heat is provided the wax melts. Melting of, we can say melting of wax is faster in copper metal rod. So from that, what can we conclude? We can say copper, iron, aluminium, all of them conduct heat well. So we can say copper, iron and aluminium conduct heat well. Or we can say they are good thermal conductors. Another term, thermal conductors. So we can either say they can conduct heat well, or we can say they are good thermal conductors. So like I said before students, usually metals are good thermal conductors. So here copper, iron and aluminium, all of them are good thermal conductors. So you can understand they show properties of metals. But if you take, let's say, carbon graphite or sulfur, then they don't conduct heat. So they are not good thermal conductors. They don't conduct heat. So they do not show properties of metals. Is that clear to you all, students? So with that, I will move on to the next slide where we discuss another property of elements. So here, in order to examine electrical conductivity, a simple circuit should be constructed. So we need to have a simple circuit. In that we need to place different materials and then we need to observe electrical conductivity. Activity: observe the electrical conductivity of elements. So for that we need these materials. We need batteries. Batteries, or you can say dry cells. Dry cells, we need the conducting wires and they have to be insulated wires. And we need to have bulbs. So what do we do there? We connect the wires to the battery, then the bulb is connected to that, but we leave a space between two wires so that we can place the material in between that space and observe whether the bulb lights or not. If the bulb lights, that particular material conducts electricity. If the bulb does not light, that material does not conduct electricity. So that is how we are going to do the activity. I will move on to the next slide and there we will discuss the method again. After that, we will do the activity. This is the method. So here you can see the battery there. Battery, then these are the wires. Then you have the crocodile clips there. Here you have the crocodile clips. Clips so that you can connect the material there. Then here you have the bulb. So you construct an electric circuit on a circuit board or connecting the pieces of equipment using crocodile clips as shown. Place the substance to be tested between A and B. So this is where we will be placing the substance and observe if the bulb lights. So you can use many different substances. We can use carbon graphite, you can use iron, you can use copper, aluminium, magnesium, zinc, lead. We can even use sulfur. If you want, not only elements, you can use other materials also. We can use a piece of cloth, we can use a piece of paper, wood. Anything can be tested using this circuit. But here, since we consider only elements, we will stick to the elements. Is that clear, students? So now that you know the activity well, we will go to the lab and do this activity now. Okay, students. So now as we were trying to identify the different physical properties, we try to compare the different physical properties. In that, now we have come to a point where we are trying to understand the electrical conductivity of different elements. So to test the electrical conductivity, I have made this circuit here. So you can see the light bulb. If the light bulb comes on when the circuit is complete, then you know that the electricity is being conducted. So then we have the power supply, that's the 9-volt battery there, and the wires have been conducted. So here you can see I have the two open ends. So when I connect the two ends together, you can see the bulb light. So that means current is flowing through the circuit. So what are we going to do now? We have the different elements. I will place the elements one by one in between the two ends, terminals here, and we'll observe whether the bulb lights. So to test, we have different materials here. First we have an iron nail, then we have sulfur, then I have magnesium, lead, here is copper, then we have graphite, aluminium and zinc. We have already discussed the luster of different elements. metals. You all know metals have a luster. So I told you all I will show that to you all during this activity. Here you can see the iron nail, then magnesium, lead, then we have copper, aluminium and zinc. All of them have a shine. The surface is shiny. You all know in order to understand it more, if there is another layer, we need to scrape it with a knife or else with a sandpaper. Then you can see the luster there, the shiny surface. But here you can observe the shine from all the different metals. And if you look at sulfur, that doesn't have a shine. Same goes for graphite. It doesn't have that particular metallic shine. So from that you would have understood that physical property as well, the lustrous nature of the different elements. So now we will test the electrical conductivity. So first I will take the iron nail. So if I connect it to the two ends here. So here you can see the bulb light. So that means iron conducts electricity. Then we will take sulfur. Sulfur I will take it with the watch glass. So if I touch it on two sides, still you can see there is no light, bulb does not light. So that means sulfur does not conduct electricity. Then we have the piece of magnesium. You all can see this is a piece of magnesium strip. So if I touch it on either side, again you can see the bulb light. So that means magnesium conducts electricity. Then I have the small piece of lead. So here again, if I place the two terminals, you can see the bulb light. So lead conducts electricity. Again we have the copper metal. So when you touch the two terminals, you can see the copper conducts electricity. So whenever I touch the element, I make sure that the two terminals don't touch each other. So here you can see copper also conducts electricity. So then we have graphite. Graphite you all know is carbon. So this side and this side again you can see graphite also conducts electricity. Now instead of this piece of graphite we can also use the pencil lead. So if you want to use a pencil, what you can do is you can sharpen the pencil from both the ends and you can expose the lead of it, that is again graphite, and you can touch the two terminals to the two ends. Then also you will see that the bulb will light. So that means graphite conducts electricity. Then we have this aluminium. Again a small piece of aluminium. So if I connect it, again you can see the bulb lights. So that means aluminium also conducts electricity. Then we have the last one, that is zinc. Again if I connect it, that also the bulb light. So that means zinc conducts electricity. So from all these elements, if we consider the electrical conductivity except for sulfur, all the others they conduct electricity. So we have iron, magnesium, lead, copper, graphite, aluminium and zinc. All of them conduct electricity. And from this and from all the other observations, you all know that graphite is a non-metal. Sulfur is a non-metal. All the others, iron, magnesium, lead, copper, aluminium and zinc, they are metals. All metals conduct electricity. Usually non-metals don't conduct electricity. So sulfur does not conduct electricity, but graphite is an exception. Although it is a non-metal, it does conduct electricity. So these are the physical properties of different elements. So based on these, we can classify them as metals and non-metals. Okay students, so did you all observe what happened clearly? Were you all able to see the bulb lighting, or whenever the bulb did not light, you would have observed it clearly? I'm sure of that. So now we have to fill in this table the observations. So observations, in this first table, the first column, we have the substance placed between A and B because we were trying to understand or observe whether the substance conducts electricity or not. So for that, these are the substances that we used: iron, copper, sulfur, graphite, magnesium, aluminium, lead and zinc. And we observe whether the bulb lights or does not light. So if the bulb lights, the substance conducts electricity. If it does not light, that means the substance does not conduct electricity. So here, iron. Iron, what happened? The bulb lights. So here I will say bulb lights. Then copper, yes, the bulb lights. Bulb lights. Then sulfur, bulb does not light. I'll use a different color. We'll say does not light. Then again, graphite. Graphite you all know is an exception. Graphite is an exception. So I will use a different color. Bulb light. Then we have magnesium. Yes, bulb lights. Aluminium. Yes, you were able to see the bulb light. Then lead. Yes, bulb light. And zinc also, the bulb light. So from this, what can we conclude? Iron, copper, graphite, magnesium, aluminium, lead and zinc, they conduct electricity. But sulfur does not conduct electricity. That is the conclusion we can get from this activity. So here we can say iron, copper, then we have graphite, then I have magnesium, then there is aluminium, lead and zinc conduct electricity. But sulfur does not conduct electricity. So that is what you were able to observe. Iron, copper, graphite, magnesium, aluminium, lead and zinc, they conduct electricity. That is the conclusion. Sulfur does not conduct electricity. But from this observation, students, you can't classify graphite along with zinc, copper and aluminium because those two are different. Graphite is different from the rest. Iron, copper, magnesium, aluminium, lead and zinc, you will see they are all metals. But graphite is a non-metal, but as exception, it does conduct electricity well. Whereas sulfur is a non-metal that does not conduct electricity. So the conclusion we get from this activity is whether they can conduct electricity or not. We haven't classified the sub-elements into metals and non-metals yet. You should remember that, students. Is that clear to you all? So then, I am going to move on to the next slide. Malleability and brittleness. Malleability and brittleness. To observe malleability and brittleness, a piece of the relevant substance can be struck lightly with a hammer after placing it on a thick surface. If it turns into a sheet on hammering, it shows malleability. If it crumbles, it is a brittle substance. So what do? You take a small piece of that substance, let's say 2 pieces, and you hammer it. You hammer it on both of these. You hammer them applying a slight force. If this becomes a thin sheet, then we call it as malleable. A piece becomes a sheet. Whereas if this crumbles into tiny pieces or powder, then what do we say? Now this is when you apply a force, it crumbles into tiny pieces or powder. Then we say it is brittle. So if they can be hammered into sheets, then they are malleable. Otherwise, if they crumble into tiny pieces or powder, they are brittle. That is how we identify malleability and brittleness. When you do this, you will see on this side, you will have iron, copper, zinc, lead, aluminium. All these are malleable. Whereas on this side, you will get carbon, that is graphite, and sulfur. Those are brittle. So these are all malleable and those two are brittle. Usually metals are malleable, non-metals are brittle. So those are the properties, students. We have discussed so many properties, different physical properties: luster, sonorous sound, thermal conductivity, electric conductivity, and finally malleability and brittleness. So using all these physical properties, we will be able to classify substances as metals and non-metals. So from all these properties, I am sure it is clear to you all that these substances, these elements, iron, copper, zinc, lead, aluminium, even magnesium. We can include magnesium also there. Magnesium. These are all metals. These are all metals. And these two are non-metals. So those are the properties, physical properties that we use to identify and classify elements as metals and non-metals. I have explained how to do the activity in the previous chapter and this chapter as well. So with that, students, I'm going to end this chapter, but in the next chapter, again we will go through all these properties using that table, and then we will classify these elements as metals and non-metals. We will discuss some more uses of these metals and non-metals in day-to-day life as well. So with that, I'm going to end this chapter.